All right, part two of epithelia. I want to address a concept in the book that I think is a little bit awkward. So, the book divides epithelial tissue into two kinds of structures: epithelia, or singular, and epithelium, and glands. Right? So, epithelia and glands, where an epithelium is a surface of cells, underlain by that connective tissue, and a gland is a cluster of cells that secretes molecules. Okay? And there are two types of glands. You've got exocrine and endocrine. And this distinction is very, very important. Exocrine is the secretion of molecules onto a surface. Endocrine is the secretion of signaling molecules into the blood. So these are not signaling molecules. These are secreting signaling molecules. And these the signaling molecules that are secreted in the blood have a very specific name called hormones, right? So secrete signaling molecules into blood. And these are called hormones. Secrete molecules onto a surface. Okay, so here's some of the awkward components of this organization. First, most exocrine glands retain that hallmark characteristic feature of an epithelium. That is, it's a surface of cells. The cells are polarized with distinct apical and basal membranes, or basolateral membranes, underlined by connective tissue. There's a basement membrane. Okay, one exception to that are the epithelial cells of the liver, which they actually secrete onto a surface, but the cells don't have that typical apical polarity, and the organization of the cells is actually much more like the organization of epithelial cells that form endocrine glands. Another awkward feature of this organization is that several of our endocrine glands don't come from epithelia. That is, they come from other tissue sources. For example, the posterior pituitary comes from nervous tissue. The adrenal medulla, we have the adrenal gland. The adrenal gland has a dual origin. The outer part is epithelial in origin, but the inner part is nervous in origin. Okay? Some of the what might be called glandular tissue, endocrine glandular tissue, like the gonads, the testes, and the ovaries, don't really have the classic glandular form, at least the glands that form from epithelial cells. They don't really have that structure or organization at all. They don't come from epithelia. They come from embryonic mesoderm, and much more like connective tissue. They're organized much more like connective tissue. So endocrine is just highly, highly diverse, of which some endocrine glands have an epithelial origin. They are epithelial cells. They typically, those that have an epithelial origin and are epithelial cells do not have the hallmark structure of an epithelia, that is a surface with a polarity. One exception to that is the thyroid gland. So exocrine epithelial cells have hallmarks of epithelia An exception is the liver. All right. Endocrine is diverse, so glands arise from multiple sources. Including epithelia, nervous tissue, and we'll say connective tissue like. All right. Those that are epithelial derived or contain epithelial cells tend to have what's called a cord-like structure. Or organization, that is stacks of epithelial cells. An exception is the thyroid, which has classic epithelial organization with apical basolateral polarity, basement membrane, and a very distinct surface.